Okay, this video is about comparing experimental and normal distributions. Often you're shown a histogram of some data. So we'll start our histogram like this. So it's not very... Okay, maybe it's the leaves on a certain tree and the distribution, and the question will be, is it a normal distribution? So you need to know some of the characteristics of one of these distributions that show that it's normal. If we took the center of each of these and you can see how we get this shaped graph. So that's roughly. So some of the features of a normal distribution, whether you can say yes it is or no it's not. The curve is approximately bell-shaped. So look to see that the curve is approximately bell-shaped. It has one higher peak on it. That means it's unimodal. If I had two that were the same height, and then I maybe had one like that and one, no, I have to go down like that. These two, I have two that are the same here, and so this would be bimodal. The mode is the highest number, and if you've got two that are high, it's bimodal. One, like a unicycle, is unimodal, meaning one peak. Okay, so it's unimodal if it's normal. There's a very small percentage at the tail ends. So these tails come out to about almost nothing at the ends. You can see the one below it here. This distribution goes like that. It doesn't go down to almost nothing at the ends, whereas a normal distribution would go down to almost nothing. It's reasonably symmetrical. Now this one is a little bit skewed, but reasonably symmetrical, about the same on both sides, like a mirror in the middle. The median and the mean are the same or close. So this should be here about the mean and the median are both in the middle. And also it's not perfectly bell-shaped because the larger the sample size, the more likely it falls into that bell-shaped curve. So if it's only a very small sample, it may still be the leaves on those trees would be a normal distribution. But because it's a small sample, you haven't really got everything filled in. If you took only 20 leaves, you wouldn't get this S-shaped, bell-shaped curve. But if you took 2,000 leaves, it's more likely to fall into the bell-shaped curve. Okay, so comparing that with, for example, this other graph. If it's not normally distributed, then it may be skewed. Skewed is when we have some of the data on one side and then a long tail down the other side. It's probably not symmetrical. It could be bimodal. It could be clumped at the tail ends. Instead of having one peak in the middle, it may have some peaks at the tail ends. And that would not be a normal distribution. So an example question on the next page. Is Gina justified in thinking that the weights of baby seals are normally normally distributed? So looking at this graph, they would give you some sort of graph. Yes, it is unimodal, so we can write down and justify why it could be normally distributed. It's unimodal. It has one peak in the middle, and probably the mean and the median are about in the middle. So I'm looking for where the mean and median is. The tails are going down to almost nothing. Okay, so the tails have very little data in them. It's almost symmetrical. So these are all points that help justify why it's normally distributed. It's not perfectly distributed, but that may be because of the smaller sample size. There's a gap here you can see, but that would fill in probably if you had a larger sample. Okay, and that's how you answer that question.